Sorry, excuse me. Good afternoon, everyone. It's a real pleasure to be back here at the ELS after such a long time. My name is Aidan. I'm a science advisor at the European Astronaut Centre, and today I'm going to be wearing a couple of different caps for the next few minutes. I'll be talking to you in this presentation on three distinct topics, but are linked and all are related to the expert team of ESA, which I'll now introduce. So, first of all, what is the expert team? It's probably one of the greatest acronyms for a team in ever. So, exploration, preparation, research, and technology. It also leads to the interesting situation when people ask you, what team are you for? I work in expert. Are you an expert? No, I just work in expert. So it's a bit confusing in some regards, but we have a mandate in expert, which you can see here. Our job is to help prepare and de-risk future exploration missions, technologies running through phase 0, pre-phase A and phase A, B1, and to raise critical technologies that are important for these future exploration missions to a TRL level of 5. And then also to collaborate and instigate new international partnerships to support the exploration activities of our program. So that's a little bit about expert, and I'll be talking more about that a little bit later on. But I want to talk to you now about one of the first topics in this presentation, which is about the Argonaut lander. So you've all heard and seen different visuals and information about the Argonaut lander. This is one of the key things that for the last few years has been a big part of the expert team and what we've been pushing through. So what Argonaut is essentially, it's a mission that will allow us to bring different payloads and cargo to the lunar surface. It'll be able to deliver up to about 2.1 tons with the cargo element attached to it. It's about 4.5 meters in diameter, 6 meters tall, so quite large, and gives us a landing accuracy of about 50 to 100 meters, which is also very, very specific. And what's probably most interesting for everyone here is that it is expected each mission will obviously carry a primary payload aspect or secondary payloads, but there's also an opportunity then for new scientific payloads to be part of this. So this is a really interesting opportunity, I think, for many of the people here in the room. And already many of you have been involved in some of the studies that have been feeding into Argonaut, for which we are very thankful. So this is what it looks like. A bit more of a breakdown. You have the three major stages here. The bottom stage is the LDE, the lander descent element. Then you have the CPE, which is the cargo payload element. And on top of that, you actually the payload system there itself. So the LDE now is in a fairly advanced stage. It's been moved into phase B studies, I believe. But the other missions around the payloads are still going through various different phases. And this is something that will be hopefully seeing more activity on in the next period. Many of these activities you've probably seen or heard about before. I won't go through all of them here now in the interest of time, but you see, for example, things like the Polar Explorer mission. You see the Astrophysical Lunar Observatory for dark side radio telescopy. You also see bioscience on the moon. You also see topics like the ISRU pilot plant and the cargo logistics mission at the end there as well. So these are all missions that are being designed to potentially work with Argonaut in the future. And this is a really exciting capability that we hope to have in Europe to support science missions and logistics missions to the moon in the next decade. So that's a very quick, brief tour through what the Argonaut is and some of the mission profiles that are being examined for it. Now I'd like to talk about the second part of my presentation, which is the Sample Analogue Curation Facility. Some of you may be aware of it, but it's now actually undergone a name change. It's now called Vulcan. So the Vulcan Analog Sample Curation Facility. I'm still getting used to it. Vulcan, so apologies for any confusion here. But the Vulcan facility, it's meant to be a focal point for research around curation, as well as the characterization of analog activities. And it aims to both support de-risking of key technologies for curation, to improve confidence in a number of areas, for example, European simulants to help bring order to the Wild West of the simulant world, and also to inspire a little bit about the next generation of planetary geologists. So it's mostly around supporting the curation of analog samples, but also bringing its geoscience expertise to the wider European community. So it's already been used in that capacity. In particular, its geoscience expertise has been brought to a number of missions within ESA. So, for example, it's been actively supporting the development of the ISRU demonstrator. It's been actively supporting the development of the Lunar facility, Argonaut, the sample fetch rover breadboard, and the Prospect in the past as well. So already it's already feeding into these activities. In addition, it's been involved on improving aspects of the improving the area in simulants across Europe. For example, it's been doing a lot of work on better understanding the supply chain around simulant production, accessibility, availability, quality control. These are all very important topics to people who are working with simulants. And now we're hoping that this facility will help us to improve our confidence whenever we work with this. In addition to that, it's also been working on producing the kind of validation around these simulants and other simulant materials so that you can actually have a bit of confidence in the material you're getting from this facility, that it has a certain profile, certain characteristics that you can have some confidence in whenever you go to do your engineering or science work with simulants. And lastly, of course, Inspire. So already the Vulcan facility has been involved in a number of educational outreach activities. But in addition to that, there's already a lot of early career researchers who are gravitating around Vulcan. So we hope to have more young graduate trainees, more research fellows involved there, as well as students being part of this facility going forward. So that's an overview of Vulcan. And the third hat then is talking a little bit about spaceships. So people often ask, what are spaceships? And this is another aspect of an activity inside Expert. Spaceships are initiatives. Essentially, they represent highly motivated innovation teams who are focused on enabling new exploration ideas and concepts for the agency and for our partners that we work with. It's not just a single place. It's actually, spaceships actually represent a very dynamic network of collaborators across Europe working on low TRL technology, and with a very different focus to how we do work in ESA. We're more focused on actually practical demonstration of technologies and ideas at a very fundamental level. So kind of like a skunk works in many ways. And the spaceship teams themselves are made up of a number of research institutes and universities. They're made up of visiting researchers who come to our different facilities. A lot of students, commercial entities are also involved, and as well as ESA staff, for example, myself. As I mentioned, we're already part of Expert, and at the moment there's currently 3 spaceships running. So we have Spaceship EAC, we have Spaceship EXAT in the UK and in Harwell, and we also have Spaceship CNES, or Spaceship France in Toulouse. And on the right here, you can see the kind of thematic areas that we're involved in as spaceships. Many of them aren't really relevant to the forum here today, so I've kind of made a selection of some of the activities that we're doing that I think are nice to highlight what spaceships can bring to this kind of audience. So for example, in the area of space resources, we've been very active for many years. We have a number of active projects in our inventory that are linked to space resources, and we're looking at, again, a very skunkworks practical engineering approach to these projects. So one project we're looking into is what we call ROAST. It's regolith and sunlight. Basically, we're looking into solar assisted pyrolysis for the production of oxygen, but also other resources from the regolith. And you can see a picture of it running here on the top left of the pictures. We're also looking into the topic of ISRU construction, and in particular looking into the challenge of landing pads. Do they even work? If you could use ISRU products on the lunar surface to produce landing pad, how would you go about doing this? We're looking at all the different technologies you could use perhaps to make this happen. And here in the middle picture, you can see actually some work from one of our recent work from some of my colleagues into producing a new composite regolith material that could perhaps be used as the basis for ISRU construction or something like landing pads in the future. We're also doing work on producing a brick producing payload. So a really simple challenge for us is, how could you actually produce a brick on the moon? It sounds almost hilariously simple, but there's a lot of technology and engineering has to go into that. So we're working on that on our team. We've also been very active in the area of microwave processing for many years. So again, we've been looking into how you can use microwaves in new and slightly terrifying ways to melt and destroy regolith. So you can see in the bottom left here, we've actually come to the way to master rastering microwaves across the regolith to melt regolith in a continuous line, which is pretty unique and pretty fun, but slightly dangerous. We're also looking into new novel concepts for oxygen production. For example, looking into using plasmas, low pressure plasmas and atmospheric plasmas. How could they be used to support oxygen production on Mars or also on the moon? In the area of disruptive technologies, we do a lot of work as well in AI. We do a lot of work on AI to support crew health. So one, for example, is looking into using AI to diagnose some negative medical aspects, which I won't go into too much here, but it's a good example of how AI can be used in the spaceflight context. But for the people here, we've also been using AI to support geological analysis on the moon. So one idea is could you have an AI geological assistant with you that can help you to characterize better the rocks or the samples that the astronauts are collecting in situ on the moon on their exploration missions. So we built a geological image classifier, for example, which can give you some basic characterization of your rock samples, tell you which rocks perhaps are more interesting versus ones which are less. And also my colleague, Dr. Freya Thorsen, who's here today, has been working a lot on understanding how we can use AI and machine learning techniques to improve our understanding around lunar mineralogy, in particular using techniques that are now coming becoming more widely used to support improving mineralogical maps, for example, and supporting future missions around ISRU. It's not just Spaceship EAC. I did mention other spaceships. Spaceship France also exists, for example, and they've been doing a lot of work as well on technologies that we need for exploration. So they've been working on developing low power regenerative fuel cell systems for lunar applications. So this is something else that we're also working on. So all the different spaceships are linked together. All of them are working together. We're all working on technologies that we think are important for exploration going forward. And I think that's, most importantly, almost finished. This final slide, and not probably one of the most important ones, is you've probably heard me talking about Luna in the past, or maybe you're aware of Luna facility. This is an analog facility that we're building at EAC. And it's been a long time coming. I'll be the first to say that, but finally, it's going to actually come online the next year. So this is a very unique facility for Europe. It's something we'll be very keen to extend access to anyone who's interested to use it. And we'll be using it for training of astronauts predominantly, because we are the European Astronaut Centre, but it's also a site for technology demonstration. It's a site for validation. It's a site that can be used for a variety of different purposes. And this is a facility that we will be offering to the exploration community, hopefully from towards the middle to the end of next year. So that is my final slide. And thank you for all your interest in this one. For any of the topics I mentioned there, you could always catch myself or my colleagues who are listed here. And good news, I'm about to give the next presentation as well.
Yeah, in case you haven't had enough of Aidan.